So we have three presenters for this second talk, and we're going to start. Well, I'm not actually going to do introductions. I feel like you guys can do that yourselves. But this is all about sediment, managing sediment, this talk. So it should be pretty interesting. I'll try to keep it a 10-minute chunk of time at the end for questions, because I didn't do a good job last time. And I will look around the room also. All right, thank you.
So Josh Carvajal is actually going to be starting us off, and he just stepped out of the room, so I don't know where he disappeared to. So I'm just going to introduce myself before I start the presentation. My name is Zapata. Everybody calls me Zap. I'm one of the district wetland ecologists with the State of Vermont Wetlands Program. And so when it comes to culvert and dam removals, often you'll have wetlands in or around site, and I will get into what that means in the second portion of this presentation. So I turn it over to you to introduce yourself and take it away.
So I'm Josh Carvajal. I'm River Management Engineer with Vermont Rivers Program. I cover Bennington and Rutland County for stream alteration permitting.
Not yet. We're introducing ourselves.
I'll just go first.
Oh,
She was ahead of you.
this is yes.
Yeah, you stepped out of the room. You left me hanging.
Okay, so I really like interaction with people, so interrupt me. If something I'm saying doesn't make sense or you want to know more, raise your hand. I've got a lot of slides, a lot of stuff I can focus more time on or focus less time on, depending on your interest.
Just a quick housekeeping note. The microphones here are not for making us louder, they're for recording. So if you could talk into the microphone, that'd be great. And if anybody wants to chat with Josh during his talk, I will hand you this.
Okay, awesome.
Take it away.
So just quickly, how many contractors do we have in the room? And cool, engineers, project managers, other fisheries. Good to see you, Will. All right. So, gonna go through a bunch of different things. Basically focusing on stream alteration, regulatory requirements for sediment management on permitted projects, and then jump into some case studies. Top one, the Hermitage Club, is going to be a culvert replacement that we did this past summer. Pelletier Dam in Castleton was a dam removal stream restoration that we did 2 summers ago. Acronyms, gotta have them, okay? A couple of these, they'll be in the slides. I don't always point them out. So there they are: Vermont DEC, Construction General Permit, Stream Alteration, SAGP, that's a lot. Comes up a lot. Wetlands Non-Reporting General Permit. IP is gonna come up, Individual Permit. And a lot of you know Bankful Channel Width, Bankful Channel Depth. E-Stone, Environmental Stone. And I have to say, I worked for the state for 12 years, and probably 6 years into being a river management engineer, I finally was told that what the E of E-Stone was environmental stone. I didn't know that, so just want to point that out. E&B, Environmental Notice Bulletin, and then WQ, Water Quality. So, stream alteration permitting. Couple of different pathways for your projects, depending on the complexity. So you have stream crossings, and you have dam removal projects. Most stream crossings are going to be a registration, which is basically a low-risk project that meets the standards, gets posted to the Environmental Notice Bulletin, and there's no public comment, right? It's something that we do on a regular basis. There's really not a high risk to it. Most dam removal projects are going to be in the second category, the application. So what that does is basically puts it on public notice, because we're often dealing with multiple landowners and larger amounts of disturbance compared to like a culvert replacement project. So that goes to the Environmental Notice Bulletin as a draft permit. You get 14-day public notice period. We rarely get public comments on stream alteration permits. If we do, we need to address them. And then the last one, which is very unique projects, or projects where there is post-construction monitoring requirements related to water quality, sediment transport concerns, or channel evolution issues. That's an individual permit process. I do not like individual permits. It basically takes like what I would normally give out, which is a 1-page authorization for a project, has a lot of legal language. It's basically like a 5-page permit that we issue, and it's got all of these references. It's a pain in the butt. But we actually do it every once in a while, and that has a 30-day public notice period. So water quality monitoring for stream vault projects. These are standard conditions in the stream vault general permit. So basically, you need to minimize turbidity and have minimal discharge of sediment during construction. And you need to isolate your work area, have appropriate sediment controls to the maximum extent practical, okay? That's not very descriptive. There's a lot of subjectivity to that. So basically, there's no water quality monitoring for stream vault projects, unless you're under an individual permit. So, does that relieve you of doing erosion and sediment controls? No, because basically as a regulator, I need to be able to come to a site, see that things are being implemented either per the plan, per the pre-construction meeting, per inspection reports that updated, the inspector said do something different, the contractor needs to do that. So it's a fluid process, but we don't have a turbidity standard that you need to meet during these projects. Sorry, other permits might. If you have a stormwater permit for your area of disturbance, then you have to do monitoring during after rainfall events. So a couple of other standard conditions. Just mentioned it, you gotta comply with your stormwater permit. Common sense stuff. Your equipment can't be leaking fluid. You can't have hydraulic fluid dripping off. You can't have fuel dripping. If you're dealing with concrete, and this is more for culvert replacement projects where you're doing like concrete head walls, or concrete wing walls, or putting together precast concrete structures, you can't have that uncured concrete get discharged to the water course. Common sense stuff. So things to focus on is that all the stream vault activities require submitting a water control plan. How is the contractor going to deal with stream flows? And this is actually a more recent update to the stream vault permit. Prior to 2022, that wasn't in the actual permit. So we've changed that recently. We have a list of other changes we're going to do the next time we revise the permit. And really what that comes down to is that, the river management engineers are figuring out, okay, this is a problem that keeps on coming up on different sites. How do we address it? We address it by amending the actual permit. Phasing and sequencing plans. I don't like seeing a ton of effort go into these when the permit documents get submitted, when the design plans get submitted, because it's an engineer figuring out how the site should be phased and sequenced versus the contractor who actually does the work. So as an engineer, you're gonna look at things differently, just like I would as a regulator of how things should be done, but the group that knows how to do it is the contractor. So you can have goals, you have a project work window, you have in-stream work dates, stuff like that. You may want to avoid certain areas of a site. That can all be on the plans, but having it very detailed and then putting it out to bid often drives up bid costs because you're telling the contractor means and method. You're telling them how to do it. So this was from Pelletier Dam in Castleton, and they basically just had a nice phasing plan. And when we get into that case study, I'll explain how it kind of all went out the window. This, dewatering and flow controls. This is required. Again, this can be illustrative, descriptive, but it needs to be sufficient details to communicate the control methods the contractor wants to do. And again, I prefer these coming from the contractor versus the engineer. You can have something on the plans, again, for the contractor to get an idea about what to do. But ultimately, at the pre-con meeting, I'm going to ask the contractor, what do you want to do? So you can get really creative and have nice drawings. It can be a written description. And written descriptions provide a ton of information because if the contractor's writing it out, they're going through, this is where this size pump is going to go. This is where I'm putting sandbags. It doesn't necessarily need to be an engineered plan. It can be. This is actually from a VTrans project. VTrans requires that type of submittal where they get really detailed on their erosion sediment control and their stream flow controls. But there's a lot of information on there. Either method works. It can be a contractor handwriting notes on the design plans, taking a photo and sending it to me. I've got a lot of ability to approve different types of control methods. So when you get into dictating how different practices occur and what needs to be done, again, it starts to drive up project costs. So again, I like to defer to the contractor. This comes up quite a bit of doing precast, what are these called? The traffic control? Jersey barriers, thank you. Jersey barriers along a stream, parallel to flows to isolate the work area, and then lining it with plastic. That really sucks, to be honest. Streams are not flat, so having a fixed concrete structure set on an uneven stream bed, you get a ton of leakage, and it's a ton of effort for the contractor to do. Sandbags, especially the yard bags, the big 3x3x3 ones, they're very good for that. But again, having the contractor figure out what they want to do is really critical. Quick note. This is flows from right to left, right? They've got a in-stream sediment trap, and we've got turbidity curtain going across the channel. Everybody knows what turbidity curtain is? The floating black curtain that's got like foam on top to have it float on top of the water and then a weight on the bottom. That doesn't work when you're going across the channel. It prevents sediment from leaving. It's really made to either parallel an active bank restoration project or still water, ponds, wetland settings, or ponds and lake settings. That's when turbidity curtain works best. In-stream check dams made of stone are good for collecting some sediment if you're having flowing water come right into them. And here's another detail that showed the actual in-stream material being bermed up in order to create a diversion to keep the flow area isolated. And then you get into, if you have to do actually dewatering, you're pumping water, it needs to be filtered. That can be through a geotextile bag, that can be through a containment area, that can be over land, it can be through a vegetated area if there's sufficient length so it doesn't get back into the stream or into a surface water right away. And what this looks like in the field is, here's a sump, so it's basically an excavated pit where they put in a perforated plastic pipe and they cut holes in that pipe, surrounded it by stone, and then now they're pumping from that. So that helps lower the groundwater level within the site and also catches leakage or anything that kind of seeps from any diversion into the site. Temporary bypasses, the actual culverts are great. We don't have a sizing requirement for how big that pipe needs to be during construction. So you can picture you're going to be out at the site during the driest period, which is wonderful, and it's going to rain at some point. So you need to kind of account for overflows from your, if you have a 3-foot plastic pipe that can handle the base flows, how are your, flood flows when it gets a lot of rain, how is that pipe going to handle that, and where's the water going to go? It's something to think about. And again, those plastic, the cofferdams, the yard bags, lining those along the bank where you guys are doing work helps isolate the work area. So this was a project in the town of Bennington. They were working on bridge abutments, and they basically put yard bags in the middle of the channel, lined poly on one side, excavated out, did the abutment, rebuilt it, and then basically flipped the up end of the cofferdam to divert flows back to where they were working. So they didn't have to move those center yard bags. They basically left the middle ones where they were and then just flipped where the water went. So bed restoration in E-stone. If you're lucky.
Josh, you're okay if I interrupt for a second?
Yeah, go ahead.
Just during the dewatering thing, the fish division's going to also ask that you don't create a barrier and you maintain flow in the channel, so you're not just like pumping around. We can talk. Yeah. Anyway.
Yeah. Yes.
Yeah.
So yes, and no. If you look at the conditions of our permit, stream alteration permit, you're trying to minimize impacts to that stream. So you can't dewater 100 feet of stream when your culvert project is 30 feet in length, right? So yes. But you do have the ability to impact fish migration during the active construction unless the project's multi-year.
Sure.
Okay.
Just want to make sure that that
Yeah, we can get into the details of that if we have time at the end, for sure. So bed restoration, if you're lucky, when you do a dam removal, you're digging down to that armoring layer, that hardened layer of the original stream channel that's existed there maybe prior to the dam being constructed. And then you're kind of just building up from there. And this may come up during, geotechnical borings and probings that you do, but sometimes during construction it pops up in different locations because you can't do geotech investigations throughout the entire impoundment. So again, ideally your final stream channel would be that bed armoring layer. If not, then it needs to be restored with what we call E-stone, that environmental stone. And I'll get into the details about that. But that's basically, again, recreating a stream channel. So the gradation of E-stone, it can either be a custom mixture of salvaged bed material that may or may not need to be supplemented with larger material, or often it's going to be like a bank run, an unprocessed bank run gravel that has quarry stone amended to it. So it's not something you can go to a quarry and say, I need E-stone. It's really always going to be a custom mixture. We do have categories, so E1, E2, E3, E4. They have different velocities that they're capable of withstanding, different embedment, different Manning's end numbers when you get into modeling. So basically what we require for culvert projects is that you're sizing the E-stone, so the bed material that goes into the culvert, to at least the Q50. So the 50-year flood event, what velocities you get, that's going to be your E-stone. If it's under 9 feet per second, then you can use E1. So we do have a descriptive specification. So E1 is going to be that at least 18 inches for the longest dimension. The D50, the 50% volume, shall have at least a dimension of 12 inches. And 25% sands and gravels, under 2 inches. So that fine portion is really important because what happens is it's not stone fill like V-Trans stone fill you're putting into the stream bed or into your structure. It's stream bed material. So you have to have bony stuff that stays, you have to have medium stuff to fill in the voids, and you have to have fines that help seal the E-stone or the bed armoring that you do so that water doesn't go subsurface. A couple other notes through there. So we get into, I'll go through this really quick. So this is salvaging some bed material. They excavated out underneath the original culvert. It was appropriately sized, and then they basically put that material back in. And interesting with closed bottom structures, because we have those sediment retention baffles in them, whether it's metal for like a metal structure or precast concrete has concrete ones, those are hard to get over the top of with equipment. So often the contractor is kind of putting in a level area that may be just the stream bed material, but then it gets smoothed out from tracking back and forth in order to fill that structure. Wetting down is really important. So it's often taking your dewatering pump, hosing it down to make sure that you settle all those fines. Or it could be soaking the structure so that you actually backwater and pond water into the structure and then turn on your pump the next day, draw the water down, and you're sucking all the fine material into the void spaces. And ultimately what we're looking for is that natural stream bed. Okay, so that's it for me. Want me to open yours? You want to go ahead?
See if I can do this right.
Questions for me while we're waiting for Zap?
Great. You'll notice a big difference between Josh's presentation and mine. I tend to have a lot of photos and visuals because that's who I am. So managing sediment on construction sites, and I'm going to be kind of looking at it through the lens of the wetland program. So as I mentioned before, I'm from the wetland program, and when you're talking about culvert replacements, bridge replacements, or dam removal projects, often wetlands may be at your site, one side or the other, or in proximity to, because wetlands along streams have a jurisdictional buffer. So to make sure that we're all on the same page initially, is what is a wetland in Vermont? So this is the legal terms. And basically it means if you have surface water or soil inundation for about 2 weeks out of the growing season, you've got a wetland on site. And when you're adjacent to any lake, pond, or reservoir, then our jurisdiction actually extends out to about 6.5 feet deep, where there is a dominance of rooted vegetation. So yes, lily pads is rooted vegetation. So wetland identification. When you're on site, you should be looking for 3 things. I don't expect you to become experts in wetland delineation. That's not your job. That's why you hire an environmental consultant. But there are 3 things that should raise red flags when you get on site as a contractor and you don't have a permit in hand. You should be asking the questions. First, do you have water? Well, if you already have a stream, the answer is yes. So then the question is the water there long enough, 2 weeks out of the growing season, to actually change your soils from upland soils, your warm brown colors? So think red, orange, yellow, brown, teddy bear brown, boring brown. There's not a lot going on in it. We call it soil, not dirt. If you have water in your soil profile and it's there long enough, it's pushing the oxygen out of your soil profile. All soils have a certain amount of space in between soil particles. When you have the presence of water, it closes those spaces and decomposition happens in the absence of oxygen, changing your warm brown colors to your cool brown colors. That's when you're seeing your gray, green, blue browns, black browns. And if you start digging holes, what you may end up seeing is speckles of what looks like rust. That's actually what it is. It's oxidization. If you have water, is it there long enough? We think so. We look at our soils, we say, yeah, they're in those cool brown colors. Then we start looking at our vegetation. When we have a dominance of vegetation that prefers wet roots, and you have all 3 parameters present, then you have a wetland. Do you need to know all species of vegetation? No. But I could give you about maybe 20 species, like sensitive fern, that if you see on site, you should be asking questions. Why does it matter? Because the state of Vermont has a wetland program, and wetlands are jurisdictional. If you are doing work within wetlands, class 2 wetlands, or their 50-foot buffers, and in some towns there are also class 1 wetlands with larger buffers such as Tinmouth and Dorset, etc., then when you are doing ground disturbance, removal of vegetation, etc., you may need a wetland permit. So jurisdictional wetlands they're regulated under the Vermont wetland rules. They could be mapped on the A&R Atlas or not. The absence of a mapped wetland does not mean that it is not jurisdictional. You may still require a permit. And then those wetlands along our rivers and streams that are 2,500 square feet or larger are, by default, by law, class 2 wetlands, and therefore are afforded a 50-foot buffer. Why does it matter? Because as Laura alluded to at the beginning of our keynote speaker, there's a lot of functions and values that wetlands provide on the landscape. The state has identified these 10 specifically. And what I would like to draw your attention to for these projects: floodwater storage, water quality, fish habitat, erosion control, which also comes back to sediment management. I do have a way of bringing it back around. So does your project need a wetland permit? And this is specifically for culverts, bridges, dam removals in this context. Are you doing an activity in a class 1 or class 2 wetland? And is your activity considered an allowed use or not? And that means, are you doing any grading, filling, ditching, or dredging? Are you doing any type of removal of vegetation, such as tree cutting or conversion? And are you doing any type of construction of infrastructure, building, roads, buried utilities, culverts, head walls, etc.? If the answer is yes, then you should be asking whether or not you need a permit to proceed. If your activity is proposed outside of the wetland or its buffer, that's the key word, then you don't need a permit, green light. You might need other permits, such as a stream alteration permit, but not from me. And if the activity occurs in a Class 3 wetland, please do not take it upon yourself to determine if a wetland is a Class 2 or a Class 3 wetland. That is not your liability, because if you get it wrong, you end up in a violation. So contact your district ecologist. We do desktop reviews. We drop ourselves on Street View. You can send us photos at the location, both upstream and downstream. We can look at vegetation. We do site visits. It's easy, so don't get caught in making those your own determinations. And then if the activity qualifies as an allowed use, and that's important because culvert replacement projects could actually fall under an allowed use. I'm not going to take you down the rabbit hole of permitting because this is about sediment management during construction. But culvert replacements could be an allowed use. And most dam removal projects are also allowed uses with an approved plan that has been submitted and reviewed by the wetland program. So, impact considerations for both culverts and dams. Do you need temporary crossings? So getting back to access, do you need to do detour of local traffic? Do you have other additional impacts for utilities? You need to relocate a cable. Do you need additional stabilization techniques? Because if the answer is yes, you might need a wetland permit. Where are your staging areas? Where will your vehicles be parked? Where is your dewatering equipment being set up? Where are you going to have areas of vegetation clearing? If the answer is here, 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 and here, and there's wetlands nearby, you might need a wetland permit. And then storage of removed materials. So this comes back to sediment management. The storage of removed materials, are you keeping them on site? Or is there an off-site disposal location? Off-site disposal locations need to be cleared for concerns about wetland impacts. We've had a few projects where the off-site disposal location was identified late in the process, and it can cause delays, and as contractors know, delays can hit your bottom line. So, evaluation. From a wetland permitting standpoint, there are basically 4 tiers of permittings or permissions. This is specifically for culverts and bridges. So first, is it allowed use? Meaning replacing in kind. It's a one-time 250 square feet of new impact. If it exceeds that, then does it qualify for a non-reporting general permit, the NRGP acronym list, which is a free permit with a registration, which is typically issued the same day that you submit your registration, so it reduces delay. There's specific thresholds that your project must meet in order to qualify for the NRGP. That's where I can assist you and other district ecologists can assist you. If you exceed the thresholds for the free registration, then you're into the normal permitting. We also have the GP, general permit, and the individual permit, just like Josh. Both of those are fee-based, based on the square foot of impact to both wetlands and buffers. There's also public noticing periods that are mandatory. Plus you have to have the review by the district ecologist to draft the permit in order for it to be issued, and so quite quickly you may end up being anywhere between a month to 6 months before you can get your permit. You have to be able to plan accordingly. So upgrading existing infrastructure, meaning if it's going to become larger than it is currently, then you may need a wetland permit. And so we should be reviewing that. This is just a cool visual, the obstructive passage to having a good passage. This would be a project type that would qualify for the NRGP because it's providing flood resiliency and aquatic organism passage. And they were able to meet the thresholds of impact to wetland and buffer by basically keeping the same front entrance. Here, this is an example in Granville, and it required a detour road. And you can clearly see where that road came across, where it's flat. And they had to calculate impacts for structures, as well as the detour road. And if you'll notice, I love it, erosion control. So we have the erosion fence. It's well mulched. This gets back to Jessica's point. It was nice and thick, and clearly there was no more sediment movement as they were working and going off-site after that detour road came out. This one also qualified for the NRGP because there is a threshold for the need for detour roads. Dam removals. So everything I just talked about, you need to consider the same things for dam removals. Where are your access, where is your staging, where is your sediment disposal, and then how are you going to manage for your sediment? And I should note, there is often years of work that takes place. If you remember Laura's slides where people just kept coming up on screen. Well, all of that takes time, and when it comes to wetlands, we really can only identify them during the growing season. Why? Because plants are dead and soils are frozen during the winter. So it takes years to get to a point of actually having a finalized design plan and implementation of those designs. So before the first bucket full of earth has taken place, there's been a lot of investment of time. Your job is to follow the approved plan, because there have been so many people who have reviewed that plan to get it to the point of approval. So if you as a contractor are going to be making changes, they may be totally appropriate, but they still need to be communicated. And that's a big piece of the dam removals, is communication, communication, communication. Otherwise, you may end up with an unexpected outcome or violation. And we're going to get into case studies that are going to demonstrate that. So dam removals, is it an allowed use? It is if it's an approved plan. Can you use timber mats? Colby was talking about that. The use of timber mats can be an allowed use, swamp mats, instead of having to clear a whole swath of vegetation. Where is your sediment disposals? Are they identified and have they been cleared? And if for some reason, aspects of this can't meet the allowed uses, then certain components of a project may require a wetland permit, even though the majority of the project itself is approved. And it's a case-by-case basis, coming back to communication and everyone that's been involved. So plans can be approved even if there is an expected loss of wetland due to the removal of a structure. And that's somewhat not intuitive, because I'm like, I want to protect all the wetlands. That's why we have a wetland program. But it's returning a system back to its natural hydrologic function. And that is restoration, which means that if there was wetland there due to the level of inundation because of a dam, then that wetland might not have ever been there before the dam was in place. So do we need to protect it? I would argue not. And we have projects that go both ways. A lot of dam removals actually result in a net gain of wetland and wetland restoration and connectivity to the floodplain. So partnerships, yeah, look at you, aren't you cute? Partnerships, funding mechanisms, regulatory entities, Army Corps of Engineers, dam safety, floodplain managers, river program, wetland program. All of us influence a final design with an approved plan that may be connected to permitting or other conditions. So stick to that plan, and a lot of it comes down to management of sediment so that you don't end up with a discharge event that results in a violation. So we're going to move into case studies, and I'm going to kick us off, and then Josh is going to supplement. And we have a contractor here today. He'll be introducing himself, Tom, who worked on one of these projects, and he's going to talk to you about his perspective and experience on a specific case study. So, if you are bidding, and you went through this already, so I don't have to spend much time, you should be reviewing all of these factors. Access points, limits of disturbance, methods of dewatering, what are your E&S controls, where are your disposal locations, how are you managing invasive species, contaminants, what is your time frame, do you have a contingency? During, maintaining your dewatering levels, how much of an open area do you have at one time, stabilize as you go. This comes back to sediment management, stabilize as you go. What is the weather forecast? Are you maintaining your E&S controls on site? Are you stabilizing your access? And are you able to, and are you identifying potentially emerging issues such as head cuts or areas of unexpected erosion? We have an example of that. And then after, seed and stabilize. So what does that look like? The block of black is your sediment, and then underneath is the native material. This is one job, I won't tell you what it is. I've blocked out the contractors' names, but look, 225,000 up to 750,000, average was about 400,000. As a contractor, when you're bidding, you need to be realistic. You need to understand the scope of work, and a lot of it comes down to sediment management. Why? Because every plan has one of these. Water control, erosion control, invasive species. And when you read through the construction sequence notes, it's all about submitting what? Your E&S plan, a pre-construction meeting, installing your E&S controls, waiting for appropriate conditions, maintenance of your controls over the course of the project. You may have some flexibility of what those methods and structures look like, but they need to be there and they need to be maintained. So Conley Pond, what's going on with Conley Pond? This was one. And this project, we actually dewatered the season before the project was implemented. And what's unique about this one is, once again, we have the page and it's sediment removal. But not all sediments need to be moved off site. So some sediments actually got used on site to reshape areas of the land back to native grades where they had been originally cut and placed. So 5 to keep talking, 10 for questions. We're going to go quickly. Communication, and the timeline was we're going to end in July. The reality was in August, and I'm going to particularly call your attention to the red areas. Good communication and being prepared. Pre-construction meetings, huge. Josh alluded to that as well. Let's make sure that we're all on the same page. You can use a variety of techniques on site. Maybe you're only using one, maybe you're using a combination. The use of things like geotextile to create temporary access, firm travel surfaces, reducing excessive rutting and sediment discharges. Limits of disturbance. So this was important because the original plan actually had excavation through the floodplain literally out to like 1 inch to 1.5 inches. So they were basically going to scrape off all of the vegetation. We reviewed the plan and said, no, that's not going to work. And by minimizing the limits of disturbance, we minimize the area of open ground, we minimize the need for additional sediment management. Dunkley Dam in the middle of Rutland. Look how well that site is now stabilized. It required the removal of 11,000 cubic yards. And once again, considerations, you know, a lot of open area, a lot of sediment that needed to be removed. Oh, and a huge patch of Phragmites, so a non-native species, so that disposal locations were important right across the street. And if you'll notice, yes, you're responsible for sediment management of your disposal locations as well. In this case, you can see the erosion fence there. And this just gives you a sense as to how big these sites are, how much open ground, and if huge storms start moving through, what that could end up looking like. So being prepared is really important, and stabilizing as you go is important. Using sediment to direct water flows, isolate your work areas, and then stabilize as you go. So that's what the finished product looked like. And once again, everything is about sediment and invasive species. So this is the one I'm going to invite Tom to come up and discuss. This is the Wainwright Dam, and we're standing at the dam looking up through the valley, but utilizing a variety of techniques in order to manage sediment on site. And with that, I'm just going to turn it over to you so that you can talk about Wainwright. Oh, before we talk about Wainwright, don't let this happen to you, okay? Cease the sediment discharge, emergency procedures, extra impacts. This is Goshen Dam, known as Sugar Hill Reservoir. Let's just say they were not prepared. This ends up being what happened. We have to maintain water quality, you have to slow velocities, you have to remove accumulated sediment, you need temporary access. And yes, at the end of the day, you're going to get a $57,000 fine. You want to avoid that, and we're coming back to Wainwright, which went smoothly.
No, you can go. We have about 10 minutes left, so I'm going to let Tom do his presentation, and then
I'm
if
Tom
we have.
Markowski with Markowski Excavating. Josh and Zapata asked me to just talk real quickly about a project we did this summer with SLR and down in Salisbury, which overall had its challenges, but it was, like Zapata said, successful.
Good.
Yeah, so anyways, the project was to basically take off, how do you run this thing? That's forward? That's forward.
Yeah,
That's
we can
back.
get up there.
Wow, this is exciting. The project was basically to take out a bunch of sediment from an old, I believe it was like a wood mill dam that had been in use or built in the 1800s. It finally reached its life cycle, and we ended up with the project. As part of the submittal process, yes, we had to provide a sediment control plan, which when I received it, I said, well, this looks great on paper. This is what I think. I visited the site. I like it. We had an on-site meeting with Jaron Borg, SLR, and the owner, and everyone seemed to think it was a good plan. Okay, this is on you. Okay, that's nice. All right, here we go. So yeah, here it is. This is the current, those the existing conditions, and basically the dam is on that lower end there, way up here. That had to be taken out, and then there was roughly about 10,000 yards of sediment that had to be removed. And there's the proposed channel that we had to dig out, which was the darker bold lines. And over time, the intent of the project was for the river to develop its own path and follow, I think it was the blue, was the final alignment over a period of time. So back to us, we meet on site. I'm feeling pretty good about things. We meet on site, we show that our intention is to create our access points in those green areas. And our first method that I proposed was to take out the dam in the red. From there, our thoughts was to create a wider channel along the south end, which is the pink line, and kind of do this project in a couple different phases where we were to move the river into a temporary channel along the southern edge, allowing us to work mostly in a drier working area and limit the amount of discharge to a couple little surges, which were unavoidable either way. We did end up putting, I showed some pictures, Jessica showed, of our check dams that we had planned to just progressively maintain throughout the project. Yep, there's our excavated area for phase 1. That's nice. And yeah, in general, our original thought was to basically do that again in the second half of the project, and working our way out and restoring the project as we go, because that made the most sense to stabilize the site. We start the project, and my whole plans don't matter, but we stayed in communication, which was good. John is here, he's the one that did the job. What ended up happening is, I didn't show it on this one, but we created our access points, and we incrementally, in more detail, explained how we took out the dam. And it wasn't tear it down to get the water level down. We left it in phases and kind of used that as a barrier as well for sediment. As John went through, we realized that the soils were pretty wet. We created a crossing point, which I didn't show in the last one, was part of the plan. The intent, once John got going, was to basically keep the river where it is as long as we possibly could, and create our excavation to final restoration right up to the existing channel. That seemed to work a lot better. As we got going with this somewhat altered plan, we did have an on-site meeting to discuss it with SLR. I think Jaron was there, and a few others. I just can't remember, Jessica, I don't know. But anyways, the important thing was, I think that we communicated that this is gonna somewhat alter the original plan. And as long as we were all on board, we all agreed that now that we see how the material's coming out, and that once we excavated the material, there was no way we were getting back out there, that this made the most sense. And then once we finished that, we took out the rest of the river, and naturally, as we took that, opened up the stream upland, it kind of followed its own path, the river did. And it seemed to work good, and we did do it in smaller phases too, so it ended up being broken up into like 3 phases versus 2 in general. This is a big invasive species area, which we learned a lot, because yes, you have to go down more than the 2 to 3 feet. In general, in hindsight, we would have just taken it all down to final elevation and considered the whole excavated material and invasive species part of invasive species area. But again, this was the most challenging in sediment control because it was the biggest area of the project. It was, especially once we stripped all of what we thought was Phragmites down, and then we had to go back into the area and go down another foot on average, which looking back, we would have altered that and gone down the whole distance and resolved that. But we were in communication. We tried our best to follow up through stabilizing the site as we worked our way out of there. And in general, we did have some luck on our side that it was a very dry August and September. Okay, I got the notice. And then we finally finished the project coming up at the end, again, back to somewhat our original plan where we crossed the river, and due to permit restrictions where we had to be out of the river under our final week, we ended up just the pink area, we went across the river and did everything and just bailed it onto the other side so that we eliminated having to cross the river and in-stream work. So that actually where the blue is, we finished out-of-stream work in probably the first week of October. But just planning that out, communicating it, I think everybody was on the same page and understood the circumstances and was on pretty much the same page. Yeah, and the final phase was to take that out. But in doing all this, we were constantly repairing check dams, cleaning them out, replacing them, incrementally taking out the concrete old dam, and trying to limit the amount of messing with the existing stream channel and waiting till our final grades were met to finally put it where it should be. So, and there it is, once it finally got back into place. So, did I touch on everything, Josh?
Yeah.
Okay. Did you want to say anything on that? No.
Now, how much time do we have?
I had the 5-minute thing.
Okay.
4 minutes.
4 minutes.
Questions?
Well, I just wanted to point out one unique feature on this is that the use of the PALs or BDAs, and they actually chopped down a couple of the white pines. to fall into the floodplain to be to help with filtering. So even after this project was complete in managing all the sediment during construction, there's some structures that have been put into place to also help manage sediment as it reestablishes itself.
And I think to stabilize things so more sediment didn't really impede our construction. As you can see, we really tried to focus on replanting some of the shrubs that were on site. So we would take those off, set them aside, dig out what we could, a section, and sometimes it was 20 feet or more in that range, and then set back and take those shrubs and put them right back in and replanted that probably within 2-day range.
A
So,
lot of red osier dogwood.
yes, that stuff.
All right, let's give a round of applause for it. We have a little bit of time for questions, so if anybody has a question, let me know, raise your hand, and I'll bring you the mic.
I was wondering if there's any special considerations or methods that you implement when you're dealing with contaminated sediment, less so relating to disposal, but more so like in-stream work, flow control, and dewatering.
So great question. I have no experience on projects with contaminated sediment. We just lucked out. Have you worked with contaminated sediment at all?
No, I have not. No. I think it's just been more of the Phragmites that we dealt with in this particular project. And we ended up having a dump site where we were within range of this, where we have a permitted site anyway, so that expedited anything with invasive species that we were able to contain it into one small location. But I don't know if that is part of the actual contaminant. Are you talking contaminants like oils and stuff like that?
Yeah.
Yeah. I have not had any experience of that.
Yeah. Great question though.
Anybody else? Other questions?
Have you run the numbers on the profitability yet?
Well, I will say I grew up with a structure of our company where we've been working since the 60s with our company and business, and it's a mindset change with what this project was compared to previous projects where I will say older generations of my family members would say, oh, go in there and dig this whole thing out and get it out of there in a week and a half. You know, this was not that type of project, and I can see it going forward as not being understanding that it takes the operator to buy into what you're trying to accomplish, and patience, and a lot of patience when it's as wet as it was while you're trying to also clear up the project and not wait till the end of the job to all of a sudden seal it up and be done with it at the end and leave the whole thing open for 2 months. So I don't know if that answers your question, but there was always a learning curve on every job.
Well, and so John was the operator, and I will second that, is that no matter how much we do in preparation for these projects, when it comes to being on site and implementing those plans, it comes down to the operator. And if the operator cares, we're going to have a much better outcome than somebody who doesn't. And we have had experiences where the operator doesn't want to hear what the regulators have to say, don't really care what the inspection is showing. They just want to get it done and move on, and it's their way or the highway, and that will get you into trouble.
Great point. And Tom and I had this conversation because he was wanting me to emphasize, you know, what's the ramifications of not implementing a plan or having discharges. One, enforcement's a pain in the butt for me. That's a last resort. I basically tell the contractor, you got 3 strikes. You're gonna get a verbal warning if you can't comply. Listen to your inspector, what they wanna do, have excessive discharges. Second time, you're gonna get a written warning. After we go to that point is when I bring in the enforcement officers. Because I'd rather you work with me voluntarily than have to bring in enforcement. We bring in enforcement, you go to legal, you're gonna end up having to do it anyway, and you're gonna get fined. So that's what we let people do, but we tend to take a less, I guess, obnoxious approach and try to work with contractors. And having a contractor that is responsive and communicates is critical for all these projects.
Just briefly, so I'd say yay for getting a chance to see Tom and John in action when we got a chance to go down to the site. I just would ask Tom and John and folks who are the contractors, what type of education or training might be helpful? Like, we offer a river and roads training for municipalities, road crews. I'm desperately trying to figure out how to get the folks who run the big yellow machines to come to our trainings, because there are opportunities for sharing how the work is done, but also all of the skill sets and knowledge around rivers or expectations of wetlands. So I'd be curious from you folks if there's some enticement for trainings that you would like to see or that you think could be helpful, or if there's a format, and maybe we won't catch this totally in this training, but I'd love to follow up with you, just so we can continue to engage more with the different contractors doing this type of work. So,
And if folks don't know, Stacy Pomeroy works for the state, right?
Yeah.
Who runs those. I don't know if you mentioned that. If people know who you are, but. Okay, so it's now lunchtime. We could certainly stick around and ask more questions, but I think I'm pretty hungry, so I'm guessing other folks are too. One more round of applause for our presenters.